Imagine a world where robots aren't just confined to the sterile environments of factories, diligently repeating the same task over and over.
Right, the sort of classic image we have.
Exactly. Picture them instead in every home, every classroom, every small business, not as some futuristic luxury, but as an accessible everyday tool for everyone.
A much more integrated vision.
What if we told you that we might be standing on the precipice of an iPhone moment for robotics? A revolution as profound and transformative as, well, the advent of smartphones or the explosion of large language models.
That's a big claim, but one that's gaining traction.
Today, we're taking a deep dive into this fascinating and rapidly evolving world of physical AI and what's being called the robotics explosion. Our expert guide for this journey is Thomas Wolfe, the brilliant co-founder and chief science officer of Hugging Face.
A key figure in the AI space for sure.
This is the visionary who had the foresight to see the immense potential in transformers years ago, effectively ushering in the LLM wave that has reshaped our digital landscape.
He definitely has a track record.
And now, he's convinced that the very same inflection point is upon us for robotics.
Yeah, he has this strong conviction about it.
For this deep dive, we'll be meticulously exploring an interview transcript where Thomas discusses Hugging Face's incredibly ambitious low robot project, the significant challenges that lie ahead for physical AI, the burgeoning open source movement in robotics, and his expansive vision for what the future holds.
Lots to unpack there.
Our mission, as always, is to unpack these insights, connect all the dots, and reveal what it truly means for you, whether you're a seasoned developer, a shrewd investor, or maybe just someone who is insanely curious about how the future is being built, piece by digital and physical piece.
Trying to make sense of this rapid change.
Get ready for some serious aha moments, because this deep dive is designed specifically to give you a shortcut to understanding this rapidly evolving field without ever feeling overwhelmed by, information overload.
Let's jump in. What's truly compelling here is that Wolfe isn't just predicting incremental improvements. He's seeing a fundamental paradigm shake.
Right, not just better robots, but different robots.
Exactly. Given his remarkable track record in spotting moonshots, like his early conviction about transformers, his assertion that robotics is at the same inflection point as language models were handful of years ago. It's not a casual observation.
No, you take that seriously.
It's a deeply calculated, informed prediction based on very tangible, observable breakthroughs. The key takeaway for us is that this isn't merely about robots doing more. It's about them doing things fundamentally differently, which radically changes their potential for widespread adoption and impact.
And this wasn't a sudden epiphany, was it? He didn't just wake up one day.
No, no.
Wolfe specifically mentioned that Hugging Face started their dedicated robotics activities about 18 months ago. To me, that time frame signals a calculated strategic pivot, not a whim.
A deliberate move.
It's a response to a rapidly shifting landscape where previously isolated research areas are now converging, creating this palpable inflection point he's talking about.
Right.
So what were the specific breakthroughs that triggered his spidey sense for robotics? What did he actually see?
He vividly recalled groundbreaking work from leading labs, specifically highlighting Stanford. And these weren't demonstrations of robots just performing, basic pick-and-place tasks, which we've seen for decades.
The usual factory stuff.
Right. We're talking about incredibly complex and dexterous operations, robots tying knots with precision, meticulously folding clothes.
Folding clothes, wow.
Yeah. Even skillfully cooking by throwing ingredients into the air on a pan and catching them. These were not trivial movements. They showcased a level of nuanced control, adaptability, and, frankly, understanding that was truly unprecedented.
That does sound almost like science fiction becoming reality. So, beyond just the sheer impressive nature of the tasks, what was the underlying magic? What made these demonstrations so significant?
The core, according to Wolfe, was the ability of these robots to perform these complex tasks with very little data.
Ah, okay, the data efficiency.
That's a critical distinction because it signals a profound shift away from needing enormous bespoke data sets for every single new action. You didn't have to show it 10,000 times.
Right.
Furthermore, he emphasized their good perspective, meaning their enhanced ability to interpret sensory input in a way that allows them to truly leverage some of the world models and things like that we see really benefit from internet-sized data.
So, connecting physical action to that vast digital knowledge base.
Exactly. This directly hints at the emergence of scalable, adaptable intelligence robots that aren't just pre-programmed for a narrow set of actions, but can learn, generalize, and apply knowledge across varied, unpredictable situations.
So it sounds like we're talking about more intelligent, efficient learning, moving beyond that brute force programming approach.
Precisely.
This new wave of success must have illuminated a clear path forward, revealing that the true bottleneck wasn't the robot's physical body, which Wolf says has been there for quite some time, but its brain, its software.
That was the key insight. The hardware was, pretty capable already.
This is a huge shift. What does that truly unlock in terms of previously impossible tasks? And I guess, what does it demand from us in terms of responsible development?
Yeah, precisely. For years, the physical capabilities of robots, their arms, grippers, sensors, were advancing steadily. Yet, their practical application often felt limited to highly controlled environments.
Right, the factory floor, the lab.
Wolf's insight cuts directly to this core issue. The missing brick in robotics was fundamentally software that could adapt, that could be dynamic. This wasn't just a technical detail. It was the difference between a tool that could only do what it was explicitly told and one that could truly learn, generalize, and intelligently respond to its dynamic environment.
That adaptability is key.
And that dynamic adaptability is what opens the door to those previously impossible tasks in unstructured settings like homes or small businesses. But to your point, it certainly elevates the importance of robust safety protocols in development. You need guarantees when things are moving physically.
So for a long time, robotics development was kind of stuck in a rigid box, constrained by highly specialized software stacks and very optimal, often inflexible control models.
Very brittle, often.
This meant robots were amazing at specific, repetitive tasks in controlled environments, but struggled immensely with anything novel or unpredictable.
Exactly. Throw a slightly different shaped object at it, and it might fail.
The breakthroughs Wolf saw signaled a different kind of software, one that could learn from experience and generalize to new, unseen situations. My question is, does that leak from specialized to general purpose introduce new complexities or vulnerabilities? Is there a trade-off we should be mindful of?
That's a crucial question. This shift from static programming to dynamic adaptive software is indeed what transforms a robot from a specialized machine into a general-purpose intelligent agent. It allows for continuous learning and broader application, setting the stage for a dramatic expansion of the field.
And Wolf drew that parallel to LLMs.
A very apt parallel, yeah. The hardware for computing was always there. Powerful GPUs, massive data centers. But took the right kind of software, specifically the transformer architecture, to unlock its full transformative potential for natural language understanding and generation.
Suddenly, language tasks became commonplace.
Right. Previously, insurmountable tasks became not just feasible, but commonplace. The same, he argues, is now true for robotics. We have the physical capabilities, and now the adaptable software is emerging to truly unleash them.
So the potential upside is huge.
While it introduces complexities, absolutely.
Yeah.
The benefits in terms of flexibility and real-world applicability are immense, pushing the focus towards robust training and validation, and, yes, being mindful of those trade-offs.
That's a powerful analogy. It implies this isn't just an incremental upgrade, it's a fundamental transformation. And recognizing this profound shift, Hugging Face made a very strategic and bold bet.
They definitely went for it.
They decided to lean heavily into their core strengths: community building and the open source movement. Their aim, quite explicitly, was to do for robotics what they had so successfully done for AI in the digital realm, democratizing access and accelerating innovation.
Leveraging their platform and their community expertise.
This brings us directly to Hugging Face's ambitious venture in the robotics space, the Low Robot Project. You mentioned replicating the success of the Transformers library. So, at its core, what exactly is Low Robot trying to achieve for physical AI?
At its core, Low Robot is Hugging Face's deliberate attempt to take the incredible success of their Transformers library,
Which is huge in the AI world.
absolutely massive, and reproduce that success in the robotics field. The driving philosophy is to create a central library that everyone would use. Think about how the Transformers library became the de facto standard for anyone working with large language models, providing unified access to cutting-edge research.
The go-to place.
Exactly. Low Robot aims for that same ubiquitous adoption and standardization in robotics.
So it's not just about a single tool. It's about building an entire integrated ecosystem, a comprehensive platform for physical AI development.
That's the key, the ecosystem.
And Wolf highlighted 3 critical aspects that Low Robot aims to combine for developers: policy models, dataset, and actuators, which he clarifies as the hardware part of robotics. This convergence is absolutely essential, isn't it?
Absolutely. Without all three, the ecosystem remains fragmented and much harder to navigate for developers.
Can you break those down a bit? Policy models?
Policy models, for the uninitiated, are essentially the AI's decision-making system, the brain, that dictates how a robot chooses its actions based on its environment and goals.
Okay. And data sets?
Datasets are the fuel for training these models, enabling learning and adaptation. The more diverse and high quality the data, the better the robot learns.
And actuators are the physical bits.
Right. The physical components, the muscles, the motors, grippers, sensors, anything allowing the robot to interact with the real world.
Got it.
Just as the Transformers library democratized access to powerful language models by providing an easy-to-use interface to the latest algorithms and pre-trained models, Low Robot seeks to do the same for physical AI. It brings all the latest technology, all the latest algorithms that people use to train robots efficiently, and all the latest data sets into one accessible platform.
This sounds like it could dramatically lower the barrier to entry for robotics development. If developers don't have to build every component from scratch or sift through fragmented resources.
It saves immense time and effort.
It opens up the field beyond specialized research labs and into the hands of a much broader developer community. That's a huge shift from how robotics was traditionally approached, right?
It's a colossal shift.
Yeah.
It transitions robotics from a niche, highly specialized domain, almost like, arcane knowledge,
Right, requiring years of specific training.
to a more accessible horizontal field. And what's interesting is that Hugging Face's role in this new physical AI world might be even more crucial and nuanced than it was for digital AI, particularly when it comes to fundamental concerns like safety and control.
That's a bold claim. How does Hugging Face's role evolve in the robotics space? Their overarching goal of building communities and bringing people into the idea that AI can be open source, something you can tweak, you can train, you can control, you can host where you want, that remains constant. But in robotics, does that take on a fundamentally different weight?
It absolutely takes on a much greater weight. This commitment to open source is fundamentally about empowerment, enabling users to be creators and controllers of AI, rather than just passive consumers.
Which is core to their philosophy.
But in robotics, this concept of control, especially hosting where you want, takes on a far more critical dimension. Wolf posed a stark yet very relatable scenario.
For Wi-Fi example.
Yeah, if your robots lose connection to the Wi-Fi or something and then run in the wall, or maybe, I don't know, running your kids, it's going to be much more dramatic than, just an LLM hallucinating.
Yeah, no kidding. That brings up a critical point. The stakes are so much higher when AI moves from digital bits to physical atoms. How do we build public trust around this local control and ensure these safety measures are truly robust?
It's paramount.
A chatbot generating nonsense is one thing, maybe embarrassing or annoying. A physical robot causing harm is an entirely different and far more dramatic concern.
Exactly. The ability to run models locally on the hardware, independent of a distant API, provides a crucial layer of safety, privacy, and control. It mitigates risks associated with connectivity loss, potential external manipulation, or even just unpredictable API behavior or latency.
Things you can't control if it's running elsewhere.
Right. Wolf explicitly stated that this suggests Hugging Face's role is maybe even more important for safety and the future of robotics than it is in LLMs. This level of local control and transparency could very well be a defining factor for public trust and the eventual widespread adoption of robots in our daily lives.
It has to be.
Without that trust, consumer adoption would be severely hampered, maybe even stalled completely.
So the community and open source ethos that Hugging Face champions aren't just about collaboration or faster innovation. They're also deeply intertwined with building a safer and more trustworthy robotic future.
See it as integral.
This ambitious vision, with its emphasis on community and decentralized control, is already manifesting in a rapidly growing community, which is absolutely crucial for fostering a robust open ecosystem.
Indeed. The Low Robot community is experiencing what Wolf describes as exponential growth, while not yet in the millions like their language model community.
Still early days for robotics in this sense.
Very early days. But it comprises several thousand people, estimated between 6,000 to 10,000. This rapid expansion is a very strong indicator of both significant demand and widespread interest in democratizing robotics.
And it's not just users, it's contributors too.
Yes, furthermore, the number of data sets on the Hugging Face sub specifically for robotics is also growing exponentially, signaling active contributions and a vibrant co-creative ecosystem. People are sharing what they build and collect.
And it's not just about raw numbers, it's about global reach and engagement. He mentioned a worldwide hackathon hosted by Hugging Face that drew participation from 100 locations in over 6 continents.
Incredible reach.
That's far beyond the small community of hobbyists or people very seriously building robots for factory lines that traditionally characterize robotics. This truly feels like a global movement in the making.
It truly is. This growth is particularly impressive when you consider that the current available hardware in this space is still largely what Wolf calls hobbyist hardware.
Right, the 3D printed arms?
Things like 3D printed arms or systems wired everywhere. Not exactly polished consumer products yet.
No.
The fact that so many people are engaging with this relatively rudimentary hardware suggests an immense pent-up demand for more accessible, polished, and user-friendly robotic tools.
People want to build this stuff.
They really do. The goal, as he articulates, is to make robotics a full horizontal thing. Much like AI awareness has become prevalent among software developers across various industries, it's about empowering everyone to get involved, not just a select few specialists.
So, if the community is growing exponentially, even with hobby-grade hardware, it means there's a clear appetite for more.
A huge appetite.
And that demand, it seems, is exactly what's propelling Hugging Face to make a very strategic and, frankly, bold move, stepping directly into developing mass-market hardware themselves.
A pretty major step for them.
This leads us directly to Hugging Face's bold move into hardware. Their commitment to physical AI led them to acquire their first hardware company, Poland Robotics,
A strategic acquisition.
and then to ship their initial robots, opening orders mid-July. This isn't just a small step, it's a massive strategic pivot for a company known primarily for its software hub and libraries.
It really is. This transition from being a purely software-centric company to embracing hardware development is incredibly significant. It signals a profound recognition that to truly build a comprehensive, open ecosystem for physical AI, you can't just provide the brains, you also need to ensure accessible physical embodiment.
You need the body too.
Exactly.
Yeah.
It's a big question for them, as Wolf acknowledged, maybe outside their traditional comfort zone, but a necessary step to achieve their expansive vision of democratizing robotics and bringing it to the masses.
And their first offering, the S100 robotic arm, is a clear statement of intent. They designed it to be the cheapest robotic arm at just $100.
Just $100. That's really something.
That ultra-affordable price point isn't accidental. It's designed to be a basic building block for innovators, making advanced robotics accessible to a much wider audience. It instantly lowers the bar for entry.
Massively lowers it, and it's already proving its worth. Wolf noted that the S100 has spurred significant entrepreneurial activity, with many startups already being built on top of the robot.
Really? That quickly?
Yeah, people are taking this foundational component and using it to automate manual tasks or to build entirely new physical world applications. Imagine a small startup using an S100 to precisely automate a repetitive assembly task, or maybe for quality control in a small manufacturing shop, or even artists using it for installations.
The possibilities are wide open at that price.
Absolutely. This aligns perfectly with Hugging Face's ethos of providing basic components that empower people to build really crazy things on top. It's about igniting innovation from the ground up, allowing anyone to experiment with physical AI.
The S100 sounds like a phenomenal starting point, fostering creativity in new businesses, but it's clearly just the beginning.
Just the first step.
The next step from Hugging Face is an even more polished, consumer-friendly device designed with a very specific goal: to truly usher in the iPhone moment for robotics.
That's right. Their new robot, Rich Mini, is priced at just $300, and it's explicitly envisioned as an impulsive buy for entertainment, fun, demo, education.
So a totally different market segment.
Completely different. This isn't about industrial efficiency or specialized tasks. It's a deliberate shift away from those traditional applications towards a much broader consumer market. The goal is to make robots accessible and engaging for everyday people, not just experts.
And presumably the expectations are different.
Crucially, yes. In this segment, reliability expectations are often lower than, say, a factory robot arm. That allows for more innovation in user experience and exploration of novel interactions without needing 5 nines uptime.
That's a fascinating distinction. So it's about sparking curiosity and interaction rather than mission-critical performance. And Wolf even compared Rich Mini to a smartphone.
He did.
He suggested it would come with initial behaviors, but the truly transformative part is that users would be able to tweak it and people can build new behavior and share them and plug all the new visual language navigation models, speech models, and chat models.
That's the platform aspect.
The possibilities are kind of endless, much like rebuilding the App Store of iPhone.
This open-ended, customizable nature is absolutely key. It's a direct response to the pitfalls of past consumer robots like Jibo. You remember Jibo?
Vaguely, yeah.
Hmm.
Didn't quite take off.
Right. They often launched with a limited set of pre-programmed behaviors. While initially charming, these robots quickly became tiresome once users had exhausted the available interactions. There was nothing new to do.
The novelty wore off fast.
Exactly. Rich Mini aims to be the reincarnation of the robot dogs of the 90s, but with true AI capabilities and a platform for continuous innovation.
So Aibo, but with like a GKT brain and an SDK.
Kind of. This is Hugging Face's pursuit of that elusive ChatGPT moment or iPhone moment in the consumer robotics space, a product that fundamentally changes how we interact with technology and opens up a new world of possibilities for creative development driven by the community.
So it's about creating a platform for ongoing discovery and personalized interaction, moving beyond static functionality.
That's the vision.
The accessibility of this hardware and software combination, the S100, Low Robot, and now Rich Mini, is really redefining who can engage with robotics, moving it out of the exclusive domain of engineers and specialists.
Oh, absolutely. And the community reflects that broadening appeal. The low robot community, as Thomas Wolfe describes it, is a fascinating mix, comprising 3 distinct types of individuals.
Okay.
This diverse user base is absolutely crucial for achieving widespread adoption and driving true innovation in the field. It powerfully illustrates that robotics is no longer a siloed, hyper-specialized field, but rapidly transforming into an interdisciplinary frontier accessible to many.
And that diversity is precisely what a breakthrough moment needs. So who are these 3 key personas shaping this new landscape?
Wolfe noted the first group as traditional roboticists. These are individuals who know how to build hardware.
The veterans.
Yeah, the folks who really understand the mechanics, the electronics. But they have historically been frustrated by the limitations of the software stack and those old, rigid, optimal control models.
They hit a wall with the old software.
Right, so they have happily joined the bandwagon because AI offers entirely new possibilities for what their hardware can actually do. Many academic labs, in particular, are finding Low Robot to be a very nice entry point for their students, which is fantastic for nurturing new talent and integrating modern AI into classic robotics education.
That makes perfect sense, giving seasoned experts a new, powerful set of tools. But what Wolfe found much more interesting is the second persona, the AI-aware developers.
The software crowd moving into hardware. Exactly. This group wasn't really into robotics before, maybe saw it as too mechanical or complex, but they now see it as a physical manifestation of AI. These are software developers eager to translate their AI knowledge into the physical world, creating a crucial bridge between digital and physical innovation.
This is where we could see truly novel applications emerge, right? People bringing LLM thinking to physical tasks.
That's where the real cross-pollination of ideas happens. And then there's a third, perhaps surprising, persona. The curious non-technical people.
Really? Even non-coders?
Surprisingly, yes. Wolfe even mentioned investors who have bought the S100 ARM just to try to understand physically what this robotic thing is. They want a tangible feel for it.
Huh. Interesting.
They're drawn by the sheer accessibility of it all. The software is just Python code, which is relatively easy to pick up. And with a little bit of vibe coding, you can actually even tweak it or control it quite easily.
Okay, vibe coding. What exactly does that mean? Is it like visual programming or something simpler?
It seems to imply a more intuitive, perhaps high-level way of interacting with the code or configuring behaviors without deep programming knowledge. Maybe natural language commands, maybe simple graphical interfaces, maybe just tweaking parameters easily.
That sounds like a game changer. The ability for non-technical users to vibe code robot behaviors intuitively is exactly what's needed to unlock creativity for everyone.
It could be huge.
Yeah.
Wolfe explicitly articulated his goal for Rich Mini. I would love my kids to be able to vibe code behavior on the robots. That signals a future where robot programming is as intuitive as building with Legos or using a simple drag-and-drop interface. It democratizes creation and unleashes a wave of innovation from unexpected places, moving robotics truly into the hands of the general public.
That broad appeal and the idea of vibe coding truly make robotics accessible to everyone, from seasoned engineers to curious kids. It's incredibly exciting.
It really lowers the barrier.
However, the journey to widespread, reliable robotics faces significant hurdles, and Wolfe was very clear about the most critical one: data.
Ah, yes, data. It always comes back to data, doesn't it?
It really does. Data is undeniably the elephant in the room. A fundamental and stark difference between language and robotics lies in data availability. For large language models, we have access to trillions of tokens of text data readily available on the internet.
An ocean of data.
In contrast, robotics faces a severe and pervasive lack of relevant, high-quality data for physical interaction. As Wolf bluntly put it, there's just not enough data there.
It's a desert compared to the text ocean.
This is a major bottleneck that needs to be addressed for the field to truly flourish and for robots to operate reliably in the real world.
I can imagine. While some videos from the internet can be used for training, say, watching humans do tasks.
Right, YouTube tutorials, maybe?
Maybe. But he points out that this is very limited. The viewpoints are often wrong. The context is missing. For automating specific practical tasks, there's often no way around just recording someone or the robots possibly just doing the task.
Which sounds incredibly laborious.
It is. That creates a huge dependency on manual data collection, which is slow, expensive, and difficult to scale. It sounds like a fundamental, almost brute force problem.
And even when you do collect that data, he mentioned another problem.
Yes, even when you do collect that data, there's a main limitation, which is diversity. A robot painstakingly trained in your own room where everything looks the same.
Your specific lighting, your specific furniture.
Exactly. That robot will inevitably have a lot of troubles to generalize if you move it to the next door room where maybe the walls are green instead of red, or the lighting is different, or the table is cluttered.
It's brittle.
Very brittle. This vividly highlights the immense need for vast, varied, and truly diverse data to enable robots to operate robustly in the unpredictable real world. Without this diverse exposure, they remain fragile to minor environmental changes.
So without that diverse data, robots remain confined to highly controlled environments, struggling to adapt to even minor changes. This generalization problem is a core hurdle for robust, real-world robot deployment, preventing them from moving beyond the lab or specialized factory settings.
It's arguably the biggest hurdle right now.
How then is Hugging Face addressing this critical data scarcity? They must have a plan.
Exactly. And recognizing this critical data scarcity, Hugging Face is tackling it head-on, leveraging its community, and exploring a new frontier in AI world models.
Okay, two approaches there. Let's start with the community.
Right. Their idea with the hub was that everyone could record data sets and then be incentivized to share them, perhaps through leaderboards, recognition, or other community dynamics.
Crowdsourcing robot data.
Essentially, yes. The long-term goal here is to build a very multicolored, multi-location data set that would be extremely diverse. This community-driven approach directly mirrors how Hugging Face successfully built vast language data sets for LLMs.
Leveraging the scale of the community.
By pooling data from countless sources and diverse environments, different homes, different lighting, different objects, they aim to expose robots to a wide range of real-world scenarios, thereby directly addressing and overcoming that critical generalization problem.
That's incredibly smart, harnessing the power of the crowd. And it's not just passive data collection. Hugging Face is also actively involved.
Yes, they're also directly working with actors of the community and robotics companies, actively releasing data sets themselves. Wolf noted an interesting dynamic. Hardware companies, who ultimately want to sell their physical products, can afford to share some of the software as open source if it brings the entire field forward, because in the end, that's not really directly what they sell.
Ah, so open sourcing data or basic models drives demand for their hardware.
Precisely. It cleverly aligns commercial interests with open source development, encouraging vital data sharing that benefits everyone, including the hardware vendors.
It's a pragmatic and effective strategy. But you also mentioned world models.
Right. Beyond community-driven data collection, a more direct thing Hugging Face is pursuing involves world models, which have recently started to pop up.
What are world models exactly? How do they help with beta?
These aren't just incremental advancements. Their emergence is linked to breakthroughs in really cool, really good image generation and open source video generation models. Think Sora, but maybe more controllable. These models learn to create coherent, controllable virtual environments. They learn the physics or rules of a simulated world from video data. This offers a new, potentially highly scalable avenue for generating synthetic training data for robots.
So generating simulated experiences instead of recording real ones.
Exactly. World models are seen as a first breakthrough in simulated generated data in quite some time. Founders in this field, according to Wolf, take these video generation models and then fine-tune them and train them to be able to react to some inputs.
How does that work in practice?
The result is a totally new experience where you actually have a film that's controllable,
Yeah.
that's both photorealistic and also reacting in a very coherent way to the actions you input. Imagine telling the simulation, move the robot arm left or pick up the red block, and the simulated video responds realistically, obeying physics and maintaining coherence.
Wow, like an interactive, realistic dream for training robots.
It's a massive leap from earlier, more rigid simulations that often lack the fidelity and dynamic responsiveness needed for effective robot training, where the skills could transfer to the real world.
That offers immense potential. This technology could be a game changer for generating more data for robots through highly realistic and controllable simulation, complementing real-world data collection in a powerful way.
It could significantly reduce the need for laborious real-world collection.
And it also has broader applications, like creating new forms of really virtual entertainment, imagine interactive movies, and a lot of applications in business, perhaps for training or planning.
The potential is vast. This could accelerate robot training significantly, reducing reliance on slow, expensive, real-world data gathering. It's a fundamental shift in how we might train intelligent physical systems.
Absolutely. So with improved data generation, both real and aesthetic, and better learning mechanisms, the discussion naturally pivots to the optimal physical form for these increasingly intelligent machines.
Right. What should these robots actually look like?
What shape will our future robot companions and helpers take? The design choice isn't just aesthetic. It profoundly impacts cost, utility, and crucially, social acceptance.
Big time.
This brings us to a big debate in the robotics world. Whether humanoids are the ultimate form factor for robots. It's a vision many of us have seen in science fiction, but how practical is it really, especially for widespread adoption?
It's a very active debate. Wolf identified two primary problems that currently limit the widespread adoption of humanoids.
Okay, what are they?
The first is expense. Humanoids are always quite expensive, largely because the actuators, the motors and joints that enable movement, make up a huge chunk of the cost, maybe 70% of the price tag.
All those moving parts add up fast.
They really do. With around 60 actuators in a typical humanoid, the cost easily pushes above that of a car, which Wolf notes is quite a high requirement for consumers who naturally expect a lot of value out of it at that price point.
Yeah, more than a car is a tough sell for most households.
While companies like Agility Robotics and Unitree are making strides in trying to cut prices, Wolf says it's really hard to get this under like $10,000. Still very expensive for a consumer device.
That's a steep price tag for something that isn't a necessity for most people. And beyond the cost, there's another significant hurdle he mentioned, which is the uncanny valley.
Yes, the creepiness factor.
It's like those old animatronics in amusement parks, impressive for their time, but after a while, they just feel off.
Right. Wolf believes that other form factors, like maybe robot dogs or simpler arms, are much more cute than the humanoid, and that the humanoid form is also asking a lot from people, right? They fall directly into that eerie, uncanny valley where something looks a lot like you, moves a lot like you, which can be distinctly off-putting for social adoption.
Human psychology, it seems, is proving to be as much a hurdle as the engineering. We're just not comfortable with things that are almost human.
It triggers something unsettling. Precisely. While humanoids theoretically offer the ability to solve a lot of tasks at the same time, essentially anything a human can do that fits the form factor, since our world is built for humans.
That's the main argument for them, right?
That's the argument. But the critical question remains, do you need to solve the humanoid? Is that the only path, or even the best one right now? The high cost, combined with the potential for social discomfort, presents significant barriers for mass market penetration.
It forces a reevaluation.
It forces a reevaluation of whether a human-like form is truly necessary or optimal for most applications, especially if the goal is broad accessibility and near-term adoption.
So instead of pouring all resources into perfecting humanoids, Hugging Face advocates for a different, more diverse future for physical AI. What does that galaxy of different form factors look like?
Exactly. Wolf explicitly stated he's much more excited about trying other form factors right now, envisioning a galaxy of different form factors. This perspective prioritizes accessibility and utility over strict anthropomorphic design.
Function over human-like form.
Right. By exploring smaller, simpler, and more specialized designs, the costs can be drastically reduced, making them attainable for more people and businesses. This aligns perfectly with their mission to democratize robotics, making them available to a far wider audience for a broader range of specific tasks.
So instead of a universal human-like butler, we might see more specialized, purpose-built robots.
That seems to be their bet. He gave examples like just one arm, like the S100, or just a moving head and this type of thing that can get cheaper. Think specialized devices for specific functions.
This really aligns with the white-labeled design philosophy he mentioned for Rich Mini, which allows businesses or individuals to adapt it for specific needs, for instance, in a hospital setting for simple delivery or interaction, rather than needing a full, expensive humanoid.
Exactly. Or maybe adapting it for retail or education or elder care. Purpose-built variations. This approach seems far more practical for immediate adoption and finding real-world use cases quickly.
Makes sense.
Precisely. Hugging Face believes this diversified approach will lead to much more robots in our life, strategically avoiding a future where robots are kind of an elite thing because they cost $100,000.
Robots for the many, not the few.
That's the idea. Their core ethos is about fostering a big community, ensuring AI is accessible to a lot of people, not just the wealthy few. Furthermore, Wolf argues that restricting AI to merely copy human limits its true potential.
How so?
He thinks AI can do something that human cannot do,
Yeah.
leading to much more fun and inventive applications that we can't even imagine yet if we only think about replicating ourselves. This encourages innovation beyond simple replication. Let robots be robots, essentially.
That's a truly expansive vision, moving beyond mere imitation to unlocking entirely new forms of intelligence and interaction.
It opens up the design space considerably.
And this philosophy of openness and accessibility extends beyond hardware design to the very models that power these robots, shaping the ongoing debate between open and closed AI.
Which is another huge topic right now.
Let's shift gears and talk about the dynamics of the open versus closed AI model race. For a while, the narrative that's been really popular was this intense battle between open and closed models, as if it was an either scenario.
A zero-sum game.
But the recent presence of OpenAI on Hugging Face hosting some of their models there indicates a much more dynamic, evolving, and perhaps coexisting landscape. What does this tell us about the current state of play?
It's definitely more nuanced than a simple battle.
Yeah.
What's fascinating here is OpenAI's own journey. They were, in the early days with models like GPT-1, very, very pro-open source.
Right. They started as an open research lab.
Exactly. Wolf even recalled how GPT-1, trained mostly on novels, would make characters always fall in love, a cute, if unexpected, quirk of its early open training data. They then shifted their strategy towards closed models, obviously.
Famously so.
But the return to Hugging Face, even in a limited way, is a significant signal that the landscape is far from static. Wolf believes that both solutions will just coexist.
Not one winner takes all.
Probably not. He cites Google's Gemma, open, and Gemini closed lines as a prime example of companies actively pursuing both open and closed approaches simultaneously. They see value in both.
Hedging their bets, maybe? Or different tools for different jobs?
Could be both. He even shared an interesting anecdote, though perhaps speculative, that he heard one Gemma model was actually so good that it was better than closed source models, so they had to not open source it, which highlights just how tight the frontier of performance can be between the best open and closed models.
Wow, that's fascinating if true. It suggests the decision isn't always purely philosophical.
Right, it's often driven by competitive advantage and performance at the very cutting edge, not always a fixed ideological stance.
That's a great illustration of the constant tension. So the choice between open and closed isn't always clear-cut. It's influenced by various factors. And it sounds like we're not exactly in a kind of cost-saving time of AI yet.
Meaning performance still often trumps cost for many users.
Right. Which means the immediate driver for open source isn't always just about reducing operational costs by running models locally. So what is currently driving companies, especially in the West, to embrace open source today?
That's the crux of it. If it's not purely about cost savings right now, the primary drivers behind this resurgence of open source models, as Wolf pointed out, are data privacy, the ability to adapt and tweak models, and the pursuit of new ideas.
Control, customization, and innovation.
Exactly. These drivers are all about control and flexibility. Companies increasingly want autonomy over their data. They don't want to send sensitive information to a third-party API.
Understandable.
They want control over their models, avoiding reliance on distant APIs that might introduce latency, security risks, unexpected changes in behavior, or even get discontinued.
Vendor lock-in is a real concern.
And crucially, The flexibility to customize and innovate on top of existing models is a significant draw. You can fine-tune an open model for your specific task in a way you often can't with a closed API.
So it's about strategic advantage, fostering internal innovation, and maybe even gaining market share through community adoption.
Right. Wolf described this as a lot of emulsion of new exploration in open source way, highlighting how openness fuels rapid experimentation and the discovery of novel applications.
He mentioned Mistral's success.
Yeah, he noted that if you want to quickly rise to the top, then open source your model. That's the Mistral recipe, indicating its power as a competitive strategy to gain rapid adoption and recognition.
And the dynamic with Chinese companies.
That's interesting too. For Chinese companies who often don't sell API in the West anyway, open sourcing their models for the Western market means they have nothing to lose in terms of API revenue. It allows them to gain mind share, developer adoption, and benchmark their models globally.
Creates interesting competitive pressure.
Absolutely. Wolf predicts that in the long term, open source is kind of a winning solution for many applications, for many use cases. As the market matures and factors like cost, local ownership, privacy, and full stack control become even more paramount.
As things commoditize a bit.
Right. And this dynamic also creates a gap or opportunity for new players to emerge and become the new top open source actor, keeping the field competitive.
This dynamic ensures a healthy, competitive ecosystem. And while the West is certainly seeing a resurgence in open source, one of the most surprising and impactful developments in the open source space has undoubtedly come from the East.
That's right. Wolf called it the most surprising thing that happened in the last 2 years.
Which is saying something in AI.
Right. The fact that China would become a champion of open source, that wasn't on anyone's bingo card for, say, 2020.
It certainly wasn't predicted by many analysts back then. Wolf's recent visit to China provided some fascinating insights into this phenomenon. What did he find?
He described a very, very competitive market internally with a lot of teams there that are extremely good. The intensity reminded him of Silicon Valley, but with a unique twist.
Which was?
These Chinese companies are extremely proud of being very open. And being open source is a key differentiator in their internal competition for talent and prestige.
Openness as a competitive advantage within China.
Apparently so. He even cited an example where a company called Zeppu decided not to open source a model, and they saw an immediate backlash. I think mostly on hiring people didn't want to come work there anymore, and so they went back to open sourcing.
Wow, so the cultural push for openness within China's AI scene is so strong that it's directly impacting talent acquisition and retention. That's a powerful indicator.
It really is. And he also emphasized that the country has extremely strong people, capable of training the best models, with some individuals reportedly involved in massive international projects like potentially GPT-5.
Top-tier talent.
Absolutely. This combination of intense internal competition for openness and an extremely strong, capable talent pool suggests that China's role as a major open source player will only continue to grow.
So we have this global competition.
Exactly. This global competitive pressure, with both East and West vying for leadership in open source, ensures that the frontier will stay quite thin between the capabilities of the best open and closed models, with each pushing the other forward rapidly.
This is a truly global race, with surprising alliances and rivalries. But while the origin of a model might raise certain questions for some users or companies,
Understandably so, given geopolitical tensions.
Wolf clarified that hesitance often stems from a more general and perhaps more fundamental issue about model safety and reliability. It's a challenge for all AI, regardless of where it comes from.
Yeah, he downplayed the country of origin-specific fear, at least based on what he's hearing. He emphasized that when it comes to Western companies potentially using Chinese open models, he sees more a general appetite for people to have a better way to understand the safety of a model, rather than a specific, widespread country of origin hesitance blocking usage.
So the concern is more universal.
It seems so. The core concern is universal across all models. People are a little bit worried about having a model that maybe will behave strangely in some cases. Will it hallucinate? Will it generate harmful content? Will it be biased? This applies equally to open or closed models, regardless of their developers or national origin. It's about trust in the technology itself.
He even gave that Humorous yet very relatable example about GPT and counting letters.
Yeah, the strawberry example. Even with GPT, sometimes you ask for the number of R's in strawberry, and it's just behaving badly, and you're like, why? You're very smart. You should be able to know that.
It perfectly highlights the inherent unpredictability and occasional inexplicable failures even in the most advanced AI models.
Right. It's not necessarily about malicious intent from the creators. It's often about a lack of consistent, guaranteed reliability that still needs to be addressed across the board.
So the need for, as he put it, guaranteeing this model will always behave well is paramount.
It's a critical area of research and development that a lot of companies have been asking for. Finding robust solutions for safety, predictability, alignment, and trustworthiness will be absolutely key to broader enterprise and consumer adoption, truly moving AI beyond experimentation into everyday utility and critical applications.
Makes sense. So beyond the commercial and practical aspects of AI development, the open source ethos also profoundly impacts a deeper, more fundamental domain, scientific discovery itself.
Yes, and this is clearly something Wolf is personally passionate about.
Thomas Wolfe has a very personal connection to this, doesn't he?
He does. Thomas Wolfe's passion for open science stems from his deep background as a physics researcher, long before the inception of Hugging Face.
What was his experience?
His personal experience vividly illustrates the historical barriers to knowledge access. He worked on superconductive materials, a field where a lot of the great research had been done by the Soviets back in the Soviet Union.
Okay, so crucial research, but hard to access.
Exactly. These groundbreaking findings were often published in Soviet GTP letters, which are scientific journals, and critically, many were still in Russian. Imagine trying to track those down and get them translated decades ago.
I can only imagine the frustration of that. Hours spent in libraries dealing with translators.
Right. This difficult process of tracking down and translating crucial research led him to a profound realization. Damn, accessing knowledge is hard. So when he eventually moved into computer science and discovered open source and platforms like Archive,
Where papers are freely available online.
it felt revolutionary. He describes it as everything's just free, basically. Everyone just shares things. It's written in English. Everyone can read it. It's even free. It was a complete paradigm shift from his previous experience in physics.
A night and day difference.
This early frustration with inaccessible knowledge clearly instilled in him the core belief that making knowledge easier to access is going to unlock a lot of really cool stuff. It's about breaking down those historical silos, accelerating the pace of discovery, and ensuring that scientific progress isn't hindered by paywalls or language barriers.
It fundamentally reshapes how knowledge flows and how quickly new ideas can build on existing ones.
Absolutely. It's about accelerating the cycle of science.
That's a powerful origin story for his commitment to open science. However, he soon realized that open publication wasn't enough. True open science required even more. What was missing?
Exactly. Wolf discovered a limit to mere open publication when he personally tried to reproduce a DeepMind paper. He found that people publish what they want to publish, the final results, the graphs.
The flashy outcome.
Right. But they don't really give you all the tricks of the trade. The little implementation details, the hyperparameter tuning, the things that actually make it work but aren't always considered novel enough for the main paper.
Hidden knowledge.
This challenge of reproducibility, where results are shared but the intricate process to achieve them is not, highlighted a critical gap. As he put it, open science for me was this extension, which is, it's nice to give open models to people so they can build things on top, but it's even better to explain how to train a model.
That's a profound distinction. He used that wonderful analogy about fishing.
Yeah. It's nice to give a fish to someone to feed them. It's even better to teach them to fish. That really encapsulates the core philosophy of Hugging Face, not just for their community, but for the broader scientific endeavor.
Sharing the process, not just the product.
Exactly. They believe AI will become a fundamental technology, much like physics or calculus, that eventually everyone could learn by reading a book.
Making the knowledge truly accessible.
This vision extends to making all the recipes to train an intelligent artifact universally accessible, which is a very long-term goal. But even in the very short term, this approach directly helps Hugging Face by encouraging people to train great models, using their tools and insights, which then in turn bring great models on the hub.
It's a virtuous cycle.
It's a virtuous cycle of knowledge sharing and community growth, where transparency fosters improvement for everyone, including Hugging Face itself.
And Hugging Face truly puts this into practice. He mentioned specific examples.
He did. He mentioned they achieved this through very long blog posts, some of which are practically book chapters, on detailed topics like how to train on 1,000 GPUs, which is incredibly complex, and how to balance the load for distributed training.
Really practical, hands-on advice.
Exactly. They also share how to make a very good quality dataset, exemplified by their own release of the FineWeb dataset, which was used by models like Qwen. And they don't just release the data, they detail how we build this dataset, how we filter it.
Showing their work, essentially.
Completely. They're not just sharing the fish, they're publishing the entire fishing manual, complete with best practices, code examples, and troubleshooting tips. It's a deep commitment to open process.
Okay, so with this foundation of shared knowledge and tools, we can now consider AI's true role in scientific discovery, not just as a powerful tool, but potentially as an innovator itself.
The million-dollar question. Can AI do science?
While there's a lot of hype about AI disrupting science and making groundbreaking discoveries on its own, Wolf, speaking as a scientist himself, believes that's really the wrong way to view science when it comes to true breakthroughs.
He has more grounded perspective.
He drew a crucial distinction between being a good student and a good researcher. How does he differentiate these, and where do LLMs fit in?
It's a great distinction. He humbly described himself as having been a pretty bad researcher, because while he could find the proof for a given problem, knowing this thing has a solution and following the steps.
Like solving a textbook problem.
Exactly. He felt he was not able to ask the right question. The true essence of a Nobel field, or a Nobel Prize, he argues, is someone who just opens a new field of research because this person just asked the right question.
The question that changes everything.
Think of Einstein's theory of relativity, born from questioning the assumption about the constant speed of light relative to the observer, which then opened up entirely new fields of physics. It's about that spark of novel inquiry, asking a question nobody thought to ask, or daring to question a fundamental assumption.
So it's about the spark of the question that revolutionizes thought, not just finding the answer to an existing one. And in his view, LLMs.
In his view, LLMs are still extremely bad at this thing, at this kind of a tasteful way to ask the right question. They are amazing at synthesizing existing information, at solving problems where the path is somewhat defined, but not yet at that truly creative, paradigm-shifting questioning.
So their role is more supportive.
Yes. While AI models for science can be superhuman in certain ways, maybe analyzing data patterns humans miss, like seeing in infrared if trained on that data, or predicting complex protein folding.
Things humans literally cannot do.
Right. Their current, most impactful role, Wolf believes, is as very useful helpers, essentially accelerators and assistants of scientific research. They are powerful tools, but perhaps not yet the originators of truly new scientific paradigms.
How do they accelerate things?
They can multiply by 10, 100, or 1,000 the predictions you can do in simulations, quickly do a full survey of what has been done across vast amounts of literature, or suggest the most logical way to test this hypothesis based on existing knowledge.
Saving researchers huge amounts of time and effort.
Exactly. They are incredibly powerful aids for human researchers, dramatically speeding up the process and expanding the scope of what's possible to investigate. However, they are not yet capable of generating the truly groundbreaking questions that open entirely new scientific fields and fundamentally shift our understanding of the universe.
That creative boundary-pushing inquiry still resides with human intellect.
For now, yes. Making humans the essential partners in discovery, using AI as an incredibly powerful amplifier.
So if AI isn't asking the really big field-defining questions yet, what big questions should we be asking about AI's own development and its long-term impact on society, and even on science itself?
That leads into his thoughts on AI's limitations and future.
As we look to the future, Thomas Wolfe highlighted one of the interesting questions in the world of AI right now, which relates to a very subtle yet potentially critical characteristic of these models.
Something you might not notice at first.
Their tendency of AI models to always agree with you. Their sort of inherent agreeableness built in through training, like RLHF.
Yeah, the helpful, harmless, honest mantra often leads to agreeableness. But this tendency is actually a significant limitation, especially in fields like scientific discovery or even just critical thinking.
How so?
Wolfe argues that a good researcher is actually a good example of someone who can disagree. Progress often comes from dissent, from challenging the status quo.
Right, you need constructive conflict.
He even mentioned a Nobel Prize-winning professor he knew who was apparently very not friendly in how he would discuss things. But that's part of it. You have to be extremely opinionated sometimes to challenge existing paradigms and make breakthroughs.
You need conviction to push against the grain.
Exactly. The real challenge, then, is finding a way to push this model to have maybe, in a way, stronger opinion or maybe a taste in their opinion. How do you train for intellectual grit or the ability to hold a potentially unpopular but well-reasoned view?
That's a fascinating challenge. Can you train for contrarianism without just creating a denialist bot?
Right. This is crucial for true scientific advancement, as breakthroughs often stem from fiercely challenging assumptions rather than passively accepting them. It might require other way to train them, other way to think about AI, possibly extending beyond current deep learning and LLM paradigms that optimize for helpfulness and agreeableness above all else.
This is clearly a big open research question for the entire field of AI, and one that could unlock entirely new capabilities if solved.
It really is.
Yeah.
And this pursuit of diverse perspectives and more creative, maybe even opinionated capabilities leads directly to Hugging Face's broader, long-term vision for the next decade.
So looking 10 years out, what does Thomas Wolfe envision for Hugging Face and for a world transformed by AI? Where does he hope we'll be?
He sees a world where everyone feel like they can build with AI and not they're just consuming AI, but they feel like they can be actor of this thing.
Empowering creators, not just consumers.
Precisely. This is a profound vision centered on democratizing creation, not just access. It mirrors the seismic shift we've already witnessed in media, moving from passive consumption of TV and radio to active content creation. Think of the rise of YouTubers, influencers, podcasters, independent creators of all stripes.
Giving everyone the tools to make things.
Wolfe believes this shift, applied to AI, will foster immense creativity and natural invention of just the community. AI, in this future, should become just another tool in their box, like a word processor or a code editor. It allows people to code stuff, but they can also train a model, and they can mess with, maybe adapt the model.
Making AI a standard part of the creative toolkit.
It's about empowering everyone to be a creator with AI, not just a user of AI products built by others.
That sounds like a fundamental reshaping of how we interact with technology and how we work.
It really is. He notes that this future will change a lot of things for society in general because a lot of this job will just be different as AI becomes integrated into workflows. And Hugging Face aims to be at the very center of this transformation, providing the essential tools, platforms, and fostering the vibrant community needed to make it a reality.
Positioning themselves as the enabler of this creator economy for AI.
Exactly. And their role in the LLM ecosystem has already provided a blueprint for how this future might unfold, showing a progressive evolution in their own strategy.
How has Hugging Face's role in the LLM ecosystem evolved over time, especially as models have pushed the frontier and the open versus closed debate continues?
It's been a noticeable shift. He mentioned that their role has switched progressively from maybe pushing ourselves a lot of things, pushing our library, pushing our early product, to more like enabling more and more the community in general.
From leading the charge to supporting the ecosystem.
Kind of, yeah. This evolution highlights their commitment to building a resilient, long-lasting ecosystem. They recognize the importance of resiliency in open source. Once a solution works reliably in production, he used the example of the BERT model, which, despite its age, is still really used a lot.
It's a workhorse.
Exactly. Users don't want to be forced to move to the new GPT every 6 months if the old thing still works for their needs. Hugging Face provides this very stable base that allows users to rely on proven technologies for the long haul, alongside providing access to the cutting edge.
Supporting the old and the new.
Right. They now work a lot with many actors of the community, mentioning tools like Llama CPP, which optimizes LLMs for efficient local execution on consumer hardware, and VLLM, a high-throughput serving engine for deploying large models to ensure the whole ecosystem can be very efficient, can work really well.
Making sure all the pieces work together.
The goal is that when one model is released, you want to be able to use it directly in VLLM. You want to be able to use it directly in Llama CPP, ensuring seamless integration and widespread utility across the community's preferred tools.
So Hugging Face increasingly sees itself as a meta community builder, almost like a facilitator or standard setter.
That's a good way to put it. Aligning different players, ensuring interoperability, and helping the entire ecosystem move forward together. This collaborative, open approach is absolutely foundational to their long-term vision of ubiquitous, accessible AI creation, whether in the digital or physical realm, truly empowering a new generation of builders.
Okay, so what does this all mean for you listening right now? We've taken a deep dive into Thomas Wolfe's profound conviction that robotics is truly on the verge of its iPhone moment.
A potential sea change.
Driven by a powerful combination of open source software like Low Robot, increasingly accessible hardware like the S100 and the upcoming Rich Mini, and a burgeoning, diverse community of creators.
All the ingredients coming together.
You've explored the critical challenges of data scarcity and the exciting promise of world models to potentially overcome them. And we've seen Hugging Face's unwavering commitment to democratizing AI, both physical and digital, and their deep passion for fostering truly open science, sharing the knowledge, not just the results.
A consistent philosophy across their work.
So here's a provocative thought for you to take away. If AI's ultimate power isn't just to answer our questions, but perhaps eventually to help us ask better, more insightful ones.
Shifting from assistant to collaborator.
And if we can all soon vibe code our own robots, interacting with and shaping physical AI as easily as we create social media posts or simple websites today, what previously unimaginable physical innovations will you bring to life? What problems could you solve in your home, your business, your community with these new tools?
What becomes possible when physical creation is democratized?
And perhaps even bigger, what new scientific questions will these powerful new tools empower humanity to ask, pushing the boundaries of what we even know to explore?
The possibilities are pretty mind-boggling.
Thank you for joining us on this deep dive into the future of physical AI. Until next time, keep exploring, keep questioning, and keep building.